Hello students, this is your 2.02 study guide help. These are really just definitions and you get them straight out of the lesson and then examples of each, and you've got to go through the lesson to get them. The hardest one down here is explain how changing energy affects intermolecular bonds to cause a change in state. And so let's look at that. Let's go through the lesson. We can make sure we have all the words, and then we can go into part B to look at those attractive forces to answer that last question. There is a video about intermolecular attractive forces, so if you need more help, I strongly recommend that you watch that video. All right, so going through the lesson. As you go through the lesson, notice that vocabulary words are either written in italics or they are clickable links that you can open. There are also some other links that you can open and view to help you understand the ideas. So the first word we're looking for is phase change, right? And we can see that the properties of solids, liquids, and gases depend on the motion of their molecules. We know motion depends on energy, right? So when matter changes from one state to another, energy is absorbed or released. So in class, I had asked you in lesson 2.01, how do we cause a substance to change phase? And the answer is to add or remove energy. So let's get a little more specific. Talking about a phase change. What is a phase change? All right. And it's matter changing from one phase to another, like a solid to a liquid to a gas. And then so our next word is endothermic, and we need an example. Here's the word endothermic. Net absorption of energy. You can actually even copy that, go in here, and paste it. Net absorption of energy. And then you need an example, such as melting, right? There's your example. So that doing this doesn't have to take a lot of time, but you do have to make the effort to go through it. You can watch the little video where you can see that solids vibrate in place and liquids flow freely. That's a nice little video. So then we can do exothermic. Exothermic is the net release of energy, right? Net release of energy. It's not about typing, it's about recognizing correct answers and being able to put them in the right places, like freezing or condensation. All right, like freezing or condensation. Melting and evaporation is endothermic. Freezing and condensation are exothermic, right? And then we're looking for our next term, condensation. What is it? So right here on page 4, and you can open it up, the process where water vapor changes from a gas to a liquid. All right. And then you're looking for examples. And it talks about the energy, it's losing energy, so the molecules slow down. And you can see the example here is dew, right? All right, dew is a product of condensation. And you can stick that in there, no big deal. All right, and then it goes on. What is evaporation, deposition, sublimation? This one talks about freezing. We all know what freezing is, right? It's when water goes from a liquid to a solid, it forms ice, it's losing energy, the temperature's going down. I didn't put a freezing on there. I put some of the harder words on there so you can go on. So melting, we know what melting is. We've all seen ice cubes melt. It's gaining energy, so it's heating up. The molecules are moving faster, and so they lose that cohesion. They lose that structure because the molecules are flowing freely around each other. It's endothermic. And now we get to evaporation. Again, evaporation, you can click on the word, changes from a liquid to a vapor. And you can get that in there. And you can see water evaporates from the pond, right? Water evaporates to turn into water vapor. All right, we can go on to deposition. Deposition is where a gas goes directly to a solid. A gas goes directly to a solid. And that is the definition. It loses energy so quickly that it totally skips that liquid phase. And then the example it gives you is frost. It's formation of frost, right? And you can put the words in there. You could, if you would rather actually do the picture, you can. You can even click on it and copy the image, and you can paste that image in there. The only thing is it's gigantic, so you're going to want to shrink that down, right? So if you'd rather have the picture instead of the words, that's fine, but shrink it down so it's not ridiculous big. Okay, and sublimation. Sublimation is the opposite of deposition. There's a little activity you can do there, but sublimation's on page 10. And sublimation is where it goes directly from a solid to a gas. A solid to a gas. And the example that they give you is dry ice. And you can see that dry ice evaporating off of there. So if you want to copy the image, you can right click and copy. You can paste it in there, or you can do the words again. That's fine. But again, if you're going to use the picture, shrink it down so it's not crazy big, and that's okay. So now we're on the last one. How do intermolecular bonds cause a change in state? And that's not really in here so much, but it is in part B. So we go back into the Learn, and you need to click into the 2.02b where it talks about attractive forces. And you can see that it's talking about these intermolecular bonds. And one of the important things to understand about the intermolecular bonds, not only is that they are between particles or molecules, but that they are kind of elastic, where they're kind of stretchy, and it takes energy to break them. You have to add energy to break them, take energy away to make them, right? So you're breaking and making these intermolecular bonds. All right. So how do you get a substance to change phase? By making or breaking the bonds. You have to have enough energy to break these bonds to allow the molecules to move freely around each other. Liquid water has some of these bonds, but they're not very strong. That's why they flow, but still stay together. Gases actually really don't have any of those bonds at all. And so you're going to want to put that in your own words here after you read through this material. All right. And then if you have questions, you can ask me, but you're going to need to put those in your own words. If you are struggling with this whole concept of the attractive forces, you can go back into the Learn, and there is a video here that is specifically about those attractive forces. You can watch the video and that will help you, but you're going to need to do this part in your own words. All right. Have a great